Okay, so on the next part of the review, they're asking us to graph and solve square and cube root functions. On part A of problem 10, they've given us the function f of x equals the square root of x plus 1 minus 3. And I've gone ahead and recognized that the parent function for this graph, or this function, is y equals the square root of x. And you can see that I've graphed it in pink. And let's go ahead and now look at the transformations that need to be applied. Well, this plus 1 tells me I need to shift left 1. And the negative 3 out in the back tells me I need to go down 3. So I'm going to take each parent point of my graph and shift it left 1 and down 3. Okay, so now looking at our domain and range, the purple graph is the one that we're interested in. That's part A, the function given to us. And the domain is my x values, and every point on my graph has an x value that is greater than or equal to negative 1. And my range is my y values, and every point on my graph has a y value that is greater than or equal to negative 3. Okay, moving on to part B. They've given us the equation y equals negative 2 times the cube root of x plus 1. Well, the parent function is y equals the cube root of x. And we're going to go ahead and apply the transformations needed. Well, this negative out in front tells me that I'm going to reflect across the x-axis. And this 2 out in front tells me that I am going to have a vertical stretch of 2. And the 1 out back tells me I'm going to shift up 1. So let's go ahead and apply those transformations. First, I'm going to reflect all of my points. So this one across the x-axis. So this one is up 2, so I'm going to bring it down 2. And let's go ahead and assign each one a color. I'll do my reflection in blue. I'll do my vertical stretch in green. And then my final graph, which I'll shift up, will be in purple. Okay, so let's start with the blue. Let's reflect every point across the x-axis. That's just giving me a mirror image around my x-axis. Notice the point on my origin didn't need to be reflected. It's going to remain in its place since it actually lies on the x-axis. Now let's do our vertical stretch of 2. This one is 2 away from the x-axis, so now I need to make it 4 away. This one's 1 away from the x-axis, so I'm going to make it 2 away. This one stays the same because it's at 0. That one is going to become 2 away, and this one's going to become 4 away. Now, all that's left to do is to shift everything up 1. So I'm going to take those points, those green points is where I ended last, and I'm going to shift them up 1. Oh, I need to change to purple. Shift every green point up 1. Okay, so those purple dots are my final little points. So I'm going to go ahead and erase my blue and green ones. Those are just for y'all to see the transformations. Okay, and then I can connect my purple dots. And that, and I didn't make a very nice smooth curve. Let me fix it for you. Is the function they've asked us to graph in part B. And if we look at it, the domain is all my x values. Well, these arrows tell me that my graph is going to continue to go left and right along the x-axis. So all my points will be all real numbers for my x values. And my range will also be all real numbers since it's going to continue to go up and down. Okay, let's move on to problem 11. They're wanting us to rewrite in rational form the cube root of 2. Well, the thing you need to remember about writing things in rational form is the number out in front of the radical goes on bottom. So this is going to become 2 raised to the 1 over 3. Now, the opposite goes for number 12. They're going to ask you to write it in radical form. Well, that means you have to put a radical or a square root sign. So you're going to take the number on bottom and send it out front. So that's going to be 7, the 7th root of 5x squared. Oh, I'm sorry. I shouldn't have said that. Because the 2 raised to the 7, or the exponent of 2 to the 7th, is only applying to the x. So it's 5 times the 7th root of x squared. Okay, now on this one, in number 13, they're wanting us to simplify this equation. So I'm going to go ahead and take care of my negative exponent inside here. And when you have a negative exponent, you send it down to the bottom. So this you can rewrite as 3 over x to the 5th raised to the negative 3 over 4. Okay, well, we still have negative exponents up here, and it's being applied to this fraction inside of our parentheses. Well, that means that when you have a negative exponent, you can flip the fraction and make the exponent positive. So instead of 3 over x to the 5th, we're going to make it x to the 5th over 3, and the exponent, like I said, becomes positive 3 over 4 instead of negative 3 over 4. Well, now we can bring this number down on the bottom out to the front. So this is going to become 4 raised to the x to the 5th over 3. And remember, we're still cubing that. That cubed part comes from this top numerator of our exponent. So now we can keep going with the 4th root of x to the, we're going to multiply these, x to the 15th over 3 cubed, which is 27. So all I did was apply this exponent of 3 inside. So now what I can do is divide this 4 into this 15. Well, 4 goes into 15 3 times. So when I do that, I'm left over with 3, because 4 times 3 is 12. So, like I said, 4 goes into 15 3 times with a remainder of 3 left over. So what I can do is I can pull out an x to the 3rd, because remember, 4 goes into 3, or 15 3 times. And then what's left over is x to the 3rd, because it has a remainder of 3 over, oh, sorry, we're still to the 4th root, over 27. So all we did there was pull out an x cubed. Okay, now what I can go ahead and do is multiply the top and the bottom by the 4th root of 3. Because that really, the 4th root of 3 is 1 over 27. So here we go. When we do that, we're left with, on the top, we're left with x cubed times the 4th root of 3x squared over 3. Okay, so that is your final answer to number 12. On number 14, they're asking us to graph exponential growth and decay functions. And in part A, they've given us the equation y equals 2 raised to the x plus 2 plus 1. And the parent function is y equals 2 raised to the x. And I've graphed that in pink. Well, this plus 2 with the x tells me I'm going to shift left 2. And this plus 1 out in the back means I'm going to shift up 1. So I'm going to take every point from my parent function and shift left 2 and up 1. Okay, and then you graph it in purple. You can see the new transformed graph, which is the equation they've given us in part A. My domain is going to be all real numbers because it's going to keep opening wider and wider to the left and to the right. My range, in this case, is that all my y values must be greater than or equal to 1. Because it has a horizontal asymptote of y equals 1. And that's going to be y equals 1. Okay, now for part B, the domain, or let's go ahead and figure out what transformations we're going to have to make here. Our parent function is y equals 1/2 raised to the x. I've graphed it in pink. This negative out front means I'm going to reflect it over the x-axis. And the -3 out back means I'm going to shift down 3. So I'm going to reflect and then shift down. And then you can go ahead and connect these purple dots. And you realize once again that your domain is going to be all real numbers because your points on your purple graph are going to encompass all x values. And the range is y must be less than or equal to -3. Because all of your y values are going to be less than or equal to -3. And the horizontal asymptote is that line, the horizontal line of y equals -3 that won't ever be touched by the graph. So that equation is y equals -3. Okay, let's move on to number 15. It says if the value of a stone increases in value by 2.5% each year, find the value of the stone after 6 years. Well, we're going to use our exponential growth formula, which is a equals p times 1 plus r raised to the t. Okay, well, P is the principal amount, the original value, which is 525. R is the rate at which it's increasing, which is 2.5%, but we have to convert it to a decimal. So that's going to be 0.025. And then the T value is 6. So A equals 525 times 1 plus 0.025 raised to the 6. And when you enter that in your calculator, you end up with $608.84. Okay, on number 16, it's the same thing, except this time we're using exponential decay formula because it depreciates. The value of the vote depreciates. So it's going to be A equals P times 1 minus R raised to the T, where our principal amount, the original value of the boat, or car, I don't know why we have two different words there, but the original amount is $28,750. The rate at which it's decreasing is 3.7% each year. When we convert that to a decimal, it becomes 0.037. And then the time that we're interested in is 3 years after the original price. So this becomes A equals 28,750 times 1 minus 0.037 raised to the 3. And when you enter that into your calculator, you end up with $25,675.40. Okay, so now looking at 17, it tells us Pierre's buying a DVD online for 10% off the list price. He has to pay $3.50 for shipping, and the total charge is $26. What is the list price of the CD? Well, if he pays 10% off, that means he's paying 90% of the list price. So, you can start off with the cost equaling $26, and then we convert 90% to 0.9 for decimal form times the list price plus the shipping fee of $3.50. And then we need to find out what the list price is equal to, so we're going to subtract 3.5 from both sides, and you end up with 22.50 equals 0.9 times x. Well, then we're going to divide both sides by 0.9. And when you divide 22.5 divided by 0.9, you end up with x equals 25. So the original list price of the DVD was $25. Okay, for number 18, they're asking us to write in logarithmic form this exponential equation. Well, that's when we're going to implement the log rule. You always start with your base, and our base here is 7. Pick up the other side, and then go back to the exponent. So it's log base 7 of 343 equals 3. Okay, now they're wanting us to write this in exponential form. So we start with our base, and the base here is 2. We pick up the negative 3, and then go back to the number. So it's 2 raised to the negative 3 equals 1 over 8. Okay, on number 20, they're asking us to solve for x. Well, in order to get x by itself, we have to log roll. So we start with our base of x, pick up the 2, and then go back to the 9. So it's x squared equals 9. Well, now we can take the square root of both sides. So x equals plus and minus 3, because square root of 9 is 3. But remember, if you take the square root of both sides of an equation, you have to put the plus and minus. Okay, on part B for 20, we're going to try and get x by itself again. We're going to subtract 3 from both sides first, and you're left with 2 raised to the x plus 1 equals 6. Then we have to log roll. So we're going to start with our base, pick up the 6, and then go back to x plus 1. So it's 2 raised to the 6 equals x plus 1. Well, 2 raised to the 6, I'm sorry, it's got to become, when we log roll from exponential, we have to convert it into a log. So it becomes log base 2 of 6 equals x plus 1. And when you type in log base 2 of 6 in your calculator, you get 2.58 equals x plus 1. And then when you subtract 1 from both sides, you end up with x equals 1.58. And you can check that by plugging it back in, and you should end up with the equation equaling out to 9. Okay, so on part C, we're going to add 3 to both sides. Remember, our whole goal is to get x by itself. So you end with 4 log base 3 of x equals 28. Then you're going to divide both sides by 4. And you end up with log base 3 of x equals 7. Then you have to log roll. So you get 3 raised to the 7th equals x. So x equals 2,187. Okay, so let's move on to D. We are now going to use natural log because we have an e here. And when we have an e, we can multiply both sides by ln, and that ends up giving me, oh wait, let's see if we can log roll actually. You start with your base of e, pick up the 12, and then pick up the negative 2x. So it's log base e of negative 2x equals 12. And log base e is the same thing as ln, so it's ln of negative 2 equals 12. Okay, and then for this one, we're going to subtract 2 from both sides. And you end up with ln of x plus 3 equals 11. Then we're going to go ahead and multiply or raise both sides to e. And that cancels these e and the ln, and you're left with x plus 3 on this side equals e to the 11th. Well, then you're going to subtract 3. So x equals e to the 11th minus 3. And when you type that in your calculator, you end up getting x equals 59,871. And let's go ahead and actually go back to part D. I'm sorry. On this case, you're going to multiply both sides by ln. And when you do that, that cancels this e out. So negative 2x equals 12 times ln. Then divide both sides by negative 2. So when you multiply 12 times ln and divide it by 2, once again, I've messed up. Part D is causing me problems. You're actually going to take the natural log of both sides. So when you take the natural log of e raised to the negative 2x, and the natural log of 12, those cancel out on the left-hand side. So you're left with negative 2x equals the natural log of 12. Well, then you divide both sides by negative 2. And when you type that into your calculator, ln of 12 divided by negative 2 equals negative 1.24. So x equals negative 1.24. Okay, we are going to omit f and g, and let's move on to 21. They're asking us to graph the following. Well, the parent function of this is, let's do it in pink, y equals log base 2 of x. And I'm going to go ahead and graph that. So now you can see our parent function of y equals log base 2 of x. And then let's look at the transformations we're going to have to make. This plus 1 inside with the x tells me I'm going to shift left 1. And this 2 out front means I'm shifting up 2. So I'm going to take each point and shift left 1 and up 2. And when I do that, my purple becomes my new graph. The domain, all of my x values are going to be greater than or equal to negative 1. And my range is all real numbers because my graph's going to keep extending up and down. Oh, I'm sorry, it shouldn't be greater than or equal to negative 1. It should be just greater than negative 1 because it's never going to actually approach this line of negative 1, which tells me also that this is my asymptote. This y equals negative 1 line, I'm sorry, x equals negative 1 line is my asymptote. Okay, so now let's move on to part B and C. Okay, so the parent function for this equation is y equals log base 1/2 x, and let's go ahead and graph those parent points. Okay, and this negative out front means I'm reflecting across the x-axis. So I need to take each point and reflect it across the x-axis. And when I do that, I end up with that purple graph. In my domain, all my x values are greater than 0. My range is all real numbers because it's going to keep extending up and down. And the equation of my asymptote is x equals 0 because that's the line that my graph will never touch. Okay, moving on to part C, let's go ahead and graph our parent function, which is y equals ln of x. And we know that that graph point that we know we can rely on is at 1, 0. Well, this inside with the x, this negative 3 is telling me I'm shifting everything to the right 3. And then I'm going to shift this negative 2 out front means I'm shifting down 2. So let's go ahead and do that. I'm going to take this point and shift right 3 and then down 2. And I'm going to mimic this graph. And my domain for this graph is x must be greater than 3 because I have a horizontal asymptote at 3. My range is all real numbers. It's because it's going to keep getting higher and higher and lower and lower. And then the equation of my asymptotes is x equals 3. All right, let's move on to problem 22. It asks us to factor completely. Well, the first thing I always check for when I'm factoring is a GCF. Well, I notice all these terms have an x. So I'm going to pull out an x as my GCF, and I'm left with x squared minus 7x plus 12 on the inside. Well, now I have a trinomial that I can factor by setting up shop. So I keep bringing down that x, and then I need two numbers that multiply to 12 but add to 7, and those are add to negative 7, 3 and 4. And they both have to be negative in order to multiply to a positive 12 and add to a negative 7. So there is my completely factored form of part A. Now part B, I look and see there's no GCF, and I also realize that there is 4 terms. Well, when I have 4 terms, I'm most likely going to factor by grouping. So I take the first 2 terms and the second 2 terms and put them together. Then what I go ahead and do is I write them as x cubed plus 9x squared plus negative 4x minus 36. Then I go ahead and factor each of those individually. Well, I notice in this first set I can pull out an x squared as a GCF, and that leaves me with x plus 9 on the inside. And then the common GCF of the second term is a negative 4. So I go ahead and pull out that negative 4, and I'm left with x plus 9 on the inside also. Well, now if you notice, this term has an x plus 9, and this has an x plus 9. So I can go ahead and pull that out. So I pull out an x plus 9 out front, and what's left on the inside is x squared and negative 4. So I can go ahead and multiply the x plus 9 that I pulled out by x squared plus 4. Oh, I'm sorry, x squared minus 4. Well, in here we notice that x squared minus 4 is a difference of perfect squares. So we keep bringing down that x plus 9. And remember, a difference of perfect squares, you put the square root of the first term as your first base, the square root of the second term, which is 2, as your second base, and then one gets a positive and one gets a negative. Okay, on 23, they're asking us to state the maximum number of possible terms and the left-right behaviors of the following polynomials. Well, to state the number of maximum possible terms, we look at the highest exponent, and in part A, that's 4. Well, max terms is always the highest exponent minus 1. So in this case, it's 4 minus 1. So 3 terms is the max terms. And then we look at whether the degree or the highest exponent is positive or negative. Well, in this case, now we need to figure out if the left or right is going up or down in this curve. Well, to figure out the left side behavior, we look at the leading coefficient. And in this case, the leading coefficient is, scratch that. Let's go ahead and put left and right in here. And you always have to find your right behavior first. And the way you find your right behavior is you look at the leading coefficient. So the right is leading coefficient. And if the leading coefficient is negative, your right side behavior is going to go down. So in this case, it's negative, so it goes down. Now, if it's even, the signs are going to match. So if the right goes down and the degree is even, then it's going to match the right side behavior. So in this case, the right went down and the degree was even, so the left went down also. Okay, now for this one, remember the maximum number of terms is 1 less than the highest exponent. So the maximum number of turns is 4. The left side and the right side, remember we look first at the leading coefficient, and the leading coefficient is positive. So the right side's going to go up, and the degree is odd because it's 5. So if the degree is odd, remember odd for opposite. So that means it's going to have the opposite behavior of the right side, so left is going to go down. Okay, so now I'm going to pass it on to Ms. Suderman to finish this out. Good luck studying, y'all.